Good day. Double integration method on theory of structures. Hello everyone, this is De La Cruz engineering video tutorial. And in this series, this is series of calculating deflection, slope, and the maximum deflection on the beam. Okay, this is part 1. And the method that we will use here, as the title shows, that will be the double integration method. Okay, for part 2, we will use the the area moment method. Okay, and with the same problem lang para ma-visualize talaga natin at ma-differentiate yung kaibahan nila. Okay, without further ado, let's start. For the beam shown, calculate the deflection and slope at point A. Locate also from A the maximum deflection, then calculate the maximum deflection. EI is constant. So first step here is to calculate the reactions. Okay, this is the pin support, this is a roller support, and the free body diagram is ito. Okay, so at the pin support, wala tayong horizontal reaction because wala naman tayong horizontal external force dito. Okay, and calculating this RB, that be summation of moment about C. Yun, that will be RB times 4 minus 10 times 5.5 minus 5 times 2 times 1. And RB is 16.25 kilonewtons. Then calculating RC, that will be just summing up forces vertical. That will be RB plus RC minus 10 minus 5 times 2. Okay? And that will be 3.75 kilonewtons. And let's substitute this to the figure. Okay. Then, in order to calculate the deflection or to use the double integration method, we will create or define a moment as a function of x. Okay? And ikakat natin yung beam kung saan lahat ng loads will be included. Okay? And we will cut it here. Dito. Okay? Ayun. Because this load here is included, this load naman, this load. So, never mind the last point of the beam. Never mind this load na. Okay? So, if we will cut this at this portion, ito yung internal reactions, that is the shear and the moment as a function of x. So, disregard na tong shear niya. Because, what is magagamit dito is yung moment as a function of x. Okay? At this cut portion, this is the distance x at the first point of the beam. Okay. Now, define the moment here, that is just 16.25 times this distance here, that will be x minus 1.5. Okay, then 10 times x. Okay, we take moment about this point, then 5 times what is this distance, that is x minus 3.5. okay, that is the resultant pa. Then multiply natin by the moment arm, which is just half of this distance here. That is x minus 3.5 divided by 2. Okay, now using the double integration formula that is derived from strain diagram, no? I mean strain of the beam. So we will not do it here. So substitute mo yung moment dyan. Yun, double prime, then 6 minus. Substitute lang. That will be the result. So I simplify this, that is 5 over 2, 2.5, then x minus 3.5 quantity squared. Okay, then we will integrate this. Okay, integrating the both sides. So recall, integration. Okay, that is a power rule, x to the n. Ito yung mangyayari. Okay, I hope alam nyo na to. Okay, because hindi naman kayo mag-theory kung hindi pa kayo dumaan sa calculus. Okay, if we integrate this both sides here, that will be the results. Okay, I hope alam nyo na to, ha? Ang pag-integrate. So, distribute mo yung integration dito. Then, we will add the constant of integration and we will call that C sub 1. Okay, again, we will integrate this. By the way, this is the slope pala of the elastic curve. Okay, then integrating again this, kayang tinatawag nating double integration kasi dalawang beses tayo nag-integrate. Okay, the same approach. Ito lang naman yung magagamit talaga natin. Okay. Okay, I hope you can follow this lang, ha, because that is in calculus. Then this is the equation of the elastic curve, equation of the curve ng ating beam. Ayun. So ano ba yung equation, ano ba yung elastic curve dito? Okay, imagine this, ha. By the way, ito yung magagamit lang natin. Okay, never mind na this, because ito lang talaga yung magagamit natin when calculating the slope and deflection. Okay, yun. Now, ano ba yung elastic curve? Ito yan. If we will plot the Cartesian plane here, and take note, nag-origin tayo at the point A. Actually, ito naman talaga yung ginagawa natin. We will be originating at point A. So this is the Cartesian plane, para mas klaro. This is 1. This is the y and x axis. This is the origin here. Now, if we will to analyze the elastic curve, because of this load here, that will bend the beam downward, and it will bend ganito. Okay, I hope may imagine nyo yan. That is essential sa atin mga engineering or engineers, ang pag-imagine sa mechanism ng ating structures. Okay, this slope, this curve is defined by this equation. Okay, and this is the slope at every points when we draw a tangent line. Okay, now first step here is to calculate the C1 and C2, and that is just by doing the boundary conditions. Okay, take note, when doing the boundary conditions is gagamitin natin yung supports at points of the support. Always yan, that is the technique talaga. Okay, at point B, that is support, when x is 1.5, our deflection here, as you can see, that is 0. Okay, ito yung 0. So if we will substitute this here, this x here, ito yung mangyayari. Okay, substitute. Okay, ginamit natin ito, ha, yung deflection formula, kasi y is 0. Then let's substitute x here, but take note of this, hindi pwedeng mag-negative yung moment arm ng ating equation. Okay, look at this. These are the moment arm here. Ito, and ito yung quantity na may x. Yan yung moment arm. Well, if you can see here, if we will substitute our x here, magiging 0 lang yan. Dito naman, that will be 5.5. But if we will substitute this dito, this term, that will be, this moment arm here will be negative. Okay? Pag nag-negative yung moment arm, hindi na natin isasali yan. Okay? Kaya hindi ko sinali dito sa equation. Okay? Take note of that, ha? Isulat nyo sa notes nyo para hindi kayo malito dito or hindi nyo malimutan. Then, simplifying this, ito yung lalabas. Okay? Take note. Calculating this in your calculator na lang. Then, i-transpose natin sa kabila. Okay? Kaya magiging ganito. Now, another boundary condition is in another support. Take note, we have two unknowns here. So, we must create another equation. Okay, by the way, let's call this equation 1. And another boundary is at point C. That is when x is this whole span of the beam, or x is 5.5. Our deflection here is of course 0 pa rin, our y. Okay, and again, using this equation dito, the deflection, substitute yung x. Okay, yan, substitute lang, 5.5, then dito 5.5, then 5.5 minus 3.5, and C1 plus C2. Now, as you can see, nasali na itong equation na to, itong term na ito, because if we will substitute 5.5 here, itong moment arm na to, hindi na to magne-negative. Okay, kaya isasali na natin yan. Okay, and simplifying this, ito yung lalabas. Okay, 5.5 C1 plus C2, then ito, this whole constant here, i-calculate nyo yan, then i-transpose sa kabila. Okay, so that is our equation 2. So we can calculate now our C1 and C2. Let me show you this. At mode 2 of our calculator, mode 5 equation, then we have two unknowns, so 1. Yan. Then substitute mo lang yung coefficients niya. Okay, that will be 1.5. Ang C2 natin here is 1. Then 45 divided by 8. Dito naman 5.5, 1, and 2575 divided by 24. Yun. So, by the way ha, if ano yung arrangement natin sa equation 1, C1 yung nauna, so dapat C1 din dito, C2 dito, kasunod, C2 din dito. Okay? Take note lang. Then, pressing equals, ito yung C1 natin, and C2 is ito. Okay? That is just 32.5. Okay, this is our C1, and this is our C2. So, the unit of C1 is kilonewton meter squared yan. Okay? You can check that. Unit analysis. Okay, and the unit of C2 is kilonewtons meter cube. Okay, now let's simplify. Na-define na natin yung equation of the slope and the equation of the deflection. Okay, we have the constant of integration. So, substitute dyan. Yun. Okay, ito yun. And ito yun. Now, to calculate the deflection at A, our boundary here is when x is 0, we can calculate our deflection, that is delta A at A. Okay, that is the deflection of A. Okay, when x is 0, take note we are in here, the deflection or the y is the deflection of A. Okay, substitute your x here in the deflection formula. By the way, ito yung deflection formula, no? And we will substitute that. Okay, 0 minus 1.5. Ito, 0 and 0 and 0. Now, take note, sinabi ko, hindi pwedeng mag-negative yung moment arm. Okay, i-detail natin dito. Isinulat ko para hindi nyo talaga malimutan. 0 minus 1.5, that will be negative. So, we will not include this. Okay? Ito naman, 0 automatic yan. Ito, 0 minus 3.5, automatic negative yan. So, hindi natin isasali. And this one naman is 0, that will be cancelled out. And therefore, the deflection of A is just negative 32.5 kilonewtons meter. Then, our EI here is constant, cross multiply. Okay, that is negative because as you can see, that is below in the Cartesian plane. Okay, kaya negative yan. Okay, that is the deflection of A. Now, the slope at A naman. Okay, slope meaning, ito yung gagamitin natin, yung slope equation. Okay, using this equation, substitute lang when x again, by the way, the slope, ang ibig sabihin yan is if we will put a tangent line at point A at the elastic curve, okay, so ito yung ating tangent line, and the slope na sinasabi dyan is from the horizontal. Ayun. Okay, if we will take the tangent of theta, ito yung horizontal nya. Okay lang, so substitute. When x is 0, y prime is theta A, or the slope at A. Substitute again. Okay, tingnan nyo. So, hindi pwedeng mag-negative. Diba? So, negative 2, that will be cancelled out. Ito rin. And of course, ito rin. And as you can see, the slope at A is positive 305 over 12. Positive because that is going upward yung ating tangent line. If that will be negative, meaning yung tangent line natin will be downward. Okay? That is the sign convention of the slope, diba? If going up yung ating line, that will be positive. Now, as you observe here, the C2 is just the deflection at the first point of the beam, and the C1 is just the slope at the first point of the beam. Always yan. Okay? So, technique na lang yan. If ever walang overhang dito, take note, if may support dito, so automatic yung C2 natin is 0 because C2 is the deflection at first point. If may support dito, meaning walang deflection dyan. So, automatic C2 is 0. Okay ba? Then, kailan mag-0 yung ating C1, which is the deflection at the first point? C1 will be 0 when the support at the first point is fixed. Because fixed support, it will be restrained. It will not freely to rotate yung ating beam at that point. 0 yung slope dyan. So, the C1 and C2 will be 0 when the first point of the beam is supported by fixed support. Okay? So, technique na lang yan para magiging hint nyo lang yan para mas madali kayo mag-solve. Okay, now we are to calculate locate the maximum deflection. Okay, so as you can see here, there are two candidates na magkakaroon ng maximum deflection. It's either the deflection at A and also this at segment BC. So, we need to locate first saan yan mangyayari at this point. Okay, from calculus, when the slope is 0, the y, the relative maximum and minimum value of the deflection will be calculated. Okay, that is from differential calculus. O, tingnan nyo, if we will draw a tangent line about here, this is not a scale drawing. Okay, the point can be in between this line or can be dito. Hindi pa natin alam. Pero check natin yan sa solution. Okay, if we will draw a tangent line here, 0 yung slope dyan. Dapat. Okay, from calculus to, maxima, minima lang. Okay, equate mo lang yung y prime to 0. Then, using this slope and y prime is 0, look at this. As you can see here, yung remaining unknown is x na lang. Okay, so, if you will do shift solve here, the x will be 2.829. Okay, sinali natin lahat. Now, look at this. After you solve your x here, i-check mo pa if may magna-negative value ba dito. We will substitute this dito. Okay, if we will substitute this 2.829 here, okay, hindi siya mag-negative. Dito naman, okay rin. But dito, mag-negative yung moment arm dito. Meaning, mali ito. Hindi ito dapat kasali. And this one here is mali. Dito rin, hindi natin ito isasali sa ating equation. Okay ba? I hope na-gets nyo. Then, if mali ito, then shift solve ulit. And hindi na natin isasali ito. Okay? So, ang lalabas dyan is ito, 2.729. Now, again, i-recheck if may mag-negative ba. If check mo dito. Ayun, hindi. Ito rin. So, hindi naman to kasali. Okay na. Okay? So, meaning the value, the location of the maximum deflection between segment BC is from 2.792 from A. Okay, so that is just maybe somewhere here. Okay, dito lang, hindi siya lumagpas dito. Okay, so using this x to calculate the deflection at that point, gamitin natin to. Okay, tingnan nyo, i-substitute natin x dito sa deflection. Again, recheck if may mag-negative yung moment arm. So if andito yan, hindi ito magne-negative. Dito, okay lang. Dito rin, mag-negative ito. So, meaning, hindi ito isasali. Okay ba? Again, substitute. Ito yung lalabas na, the deflection at that point. Now, we compare the two candidates. This is 8.03. This is 32.5. Okay? So, if that is the comparison, meaning, ito yung maximum deflection. That will be the answer dyan. And the location of the maximum deflection is 0 because andito lang tayo. Okay, so yan. That's it. So I hope you learned something from this. Please do like, share, and subscribe. Then please hit the bell icon para ma-notify kayo pag nag-upload ako ng mga panibagong video tutorial. Okay, so please comment down below rin para ganahan tayo. Okay, so thank you everyone and stay safe.